Measuring the pH of a acid solution, it just depends on whether it's a strong or weak acid. When it's a strong acid, it's really easy because the molarity of the strong acid is actually the molarity of the H. And so I know in this case that nitric acid is strong, so that my H plus is actually equal to 0.00125. So then I can just jump on the little molarity conversion chart to pH. And so I know that H plus is 0.00125. So if I minus log that, so I minus log 0.00125. And that's going to give me the pH, which comes out to be 2.9, which makes sense because if it's less than 7, then I know that that's acidic. If the answer actually came out more than 7, then the answer would actually be 7, because you cannot have an acid that is basic, and so it just means it's been watered down. So on number 2, when we look at the strong base solution, it's kind of the same deal. The only difference is in a strong base, you can have multiple OHs. So in the first example, so I'm just going to call that example A, this is just one OH, so therefore the 0.00125 molar is equal to the OH minus concentration. So if I minus log that, well, obviously I minus logged it up there, but instead of it equaling pH, it equals POH, and you have to be careful on that. So to always recognize what you have. So if I have OH, I have POH. And so in this case, to get the pH, I do 14 minus the 2.9, which gives me 11.1 is equal to the pH. And again, that makes sense. It's above 7. So, and this is a base, so it should be above 7. Now, in example B, though, notice that I have a strong base, but it's got 2 hydroxides. So in this case, I have to double the concentration. So if I multiply this by 2, I get 0.00250. So that's going to equal my OH minus concentration, which is going to make it a little bit more basic, because then when I take the minus log of that, so I'm going to minus log that number, I get 11, oh, nope, I get 2.6. I'm jumping ahead. So I know that the POH, which is equal to that, is going to equal 2.6. So then, again, to get the pH, I know that pH and POH has to equal 14. So if I subtract that, I get 11.4, which makes it a little bit more basic, which makes sense. No, did it double? No, it did not, because it's not that high of a concentration. But you have to understand that every tick, every pH change is a change in 10 times. And so it does make a pretty big difference changing it up to 0.3 higher. So that's how we do a strong acid or a strong base solution. Pretty simple.